Let's take a look at some difficult examples that involve rational exponents and roots. Again, rational exponents are when your exponent can be written as a rational number, fraction. The denominator of the fraction becomes the type of root. The numerator is the exponent outside of that. So sometimes you're going to be getting problems that only have variables in them. And whether these are variables or numbers, you're still going to be applying exponent rules and simplification processes to them. If they're variables, you can only take it so far. But if they're numbers, you can probably take it further. In that sense, you might want to have a cheat sheet of perfect squares and perfect cubes nearby to help you with that. Okay, so when you have two bases that are the same and the exponents are, the same or different, you can follow exponent rules and add the exponents together. So we're going to have 1/3 plus 3/2. And now you have to think about how do you add fractions when they don't have the same base. If your fractions don't have the same base, you're going to have to get a common denominator. I'm just going to do that over here. And so 1/3 plus 3/2, and the common denominator is going to be 6. So I'm going to multiply this fraction by something that will make it 6 in the denominator. So that's 3/3, and the other fraction 2/2. And that's going to give me 2/6 plus 9/6, which will be 11/6. And that fraction cannot be simplified. So your answer is going to be x to the 11/6. If your problem asks you to write that with roots, that would be the 6th root of x raised to the 11th. In this example, we're going to have to apply the power rule, where you multiply the outside exponent by the inside exponent. So we're going to keep the base, r, and it's going to be raised to the 5/4 times 3/2. And that's easier than the problem we just did. When you multiply fractions, you just go straight across. Numerator times numerator, denominator times denominator. So we get r to the 15/8. That fraction cannot be simplified. If your problem is asking you to write this as a root, you would have the 8th root of r, because 8 is in the denominator, and that would all be raised to the 15th. If they give you a problem that's in roots and they ask you to rewrite it with rational exponents, you are going to start by changing every root into the fractional exponent. So this would be x to the 1/2, because this is a square root, times x to the 1/4, because this is a 4th root. Then we're going to apply the power rule between the 1/4 and the 3. So I bring down my x to the 1/2. That's all going to be multiplied by x to the 1/4 times 3, which becomes x to the 1/2 times x to the 3/4. And then, because I have the same base, I'm going to be adding the exponents. So this will be x to the 1/2 plus x to the 3/4. And I have that situation again where I need to get a common denominator. The common denominator between these two fractions is 4. I'm going to multiply the first fraction by 2 over 2, change that piece of clay into a different shape, and I get 2 over 4 plus 3 over 4. So my new exponent is going to be 5 over 4. So this equals x to the 5/4. What that would be as a root, it would be the 4th root of x to the 5th. Sometimes you're going to get a problem that has numbers in it. And when that happens, you're going to need to simplify those numbers. So it's really useful to have your perfect squares and perfect cubes cheat sheet handy and ready to go. Looking at this one, we're going to have to start with the power rule, where the 3/2 is going to multiply to the 6 and then come sit with the 169. This 169 actually has an exponent of 1, so 1 times 3/2. Writing this out, I get 169 to the 3/2, and then x to the 6 times 3/2. Now I need to simplify this exponent. 6 over 1 times 3/2. Multiply numerator times numerator, denominator times denominator. I get 18 over 2, which is 9. That's a nice number we've simplified to. Bring down my work. 169 to the 3/2 times x to the 9th. Now, to simplify this term, I'm going to rewrite this with exponents. With roots. Because it has a 2 in the denominator, I know I'm going to have a square root right here. So I have square root of 169 raised to the 3rd power because the 3 is in the numerator. Bring down my 9, x to the 9th. Now, if you don't know the square root of 169, go look at your cheat sheet and you find 169, the square root of it will be 13. So I have 13 cubed, bring down the x to the 9th. I'm not finished until I cube the 13. Now I don't know what 13 cubed is, so I had to use my calculator. Typing it into the calculator, I get 2,197 x to the 9th, and now I am fully simplified. Don't forget your equal signs. So the moral of the story here is if you're simplifying numbers, either memorize your perfect cubes and perfect squares or have a cheat sheet ready. You can also do guess and check using a calculator to find your square roots and cube roots. In general, with these harder problems, you need to know your exponent rules. The multiplication rule, the power rule, quotient rule. You need to know how to also add fractions. So if you are struggling with adding fractions, go back and review that. And yeah, sometimes the problem will be easier to simplify in root form with radicals, and sometimes it'll be easier to solve or simplify if you have rational exponents. So make sure that you are capable of going back and forth between radicals and roots and rational exponents.